So what features would my ideal language have? Well, it would have a sound type system. And what a sound type system means is if your code compiles and type checks, it will not have a runtime type error. I would also prefer if my type system was based on Hindley-Milner. And Hindley-Milner is a type checking algorithm and type system found in languages like OCaml and Haskell. We'll dive into it a little bit more here in a moment, but I want my type system to work for me instead of against me. When I'm writing TypeScript, once you get past the top level and you get into the world of having to write like deeply generic types and work with type mappers and union a bunch of types together, you get into these giant ternary trees trying to capture the dynamism of JavaScript, it becomes a burden, and it takes a long time to build the muscles to learn how to be productive and work through those problems. Additionally, and this is a benefit of Hindley-Milner type systems, is I want static typing safety, but I want dynamic typing simplicity and ergonomics. Like I want to be able to move fast, and like I want my types to help me, but I don't want my whole focus to be just battling the type system. So the way Hindley-Milner works at like a high level is as you're writing code, let me back up a little bit. Hindley-Milner, you can get away with not annotating 95% of your types in your program, and it will 100% bulletproof infer the types. And this is not inference like you would see in TypeScript. TypeScript is gonna like infer a structural shape of your data, where a Hindley-Milner system is gonna infer some nominal type that you've declared elsewhere, and it's gonna figure it out by usage. And the way it does that is when it's compiling your code, is it's gonna build up these equations of constraints, looking at how you're using expressions and how you're using variables, and it basically solves those equations and says, oh, I know that this value can only be this type user because it was used in such a way and it has this field. And also, and this is an experience if you've ever written Rust, if it compiles, it's gonna run. I also want simple polymorphism in generic programming, also a nice trait found in this kind of a type system. And also, it also enables us to have some really nice compile time optimizations. The next thing I want is errors as values. I want to throw try-catch in the frickin' garbage. And a little hot take here, despite having built my career mostly in TypeScript, I have a pretty hot take on the language. So my hot take is that JavaScript has the lowest bar of entry to building and being productive, which is a good thing, but one of the highest bars of any language and stack to building high quality, stable, and reliable software. Very few devs have the expertise to pull off the ladder. At Vercel and Formidable, I've worked with some of the best JavaScript devs across the planet, and we still fall into these traps and mistakes because of the language and its runtime. And a lot of this is because of try-catch. If I could take one feature and add it to TypeScript, it would being able to annotate that a function throws, right? When you bring in a library from an NPM package, or maybe you're working in a giant repo with dozens of teams, you have no idea if a function throws or not. And JavaScript and TypeScript promote a style of programming where you focus on the happy path. It enables you to focus solely on the happy path, right? If you write some code that can throw an error, it's so easy to say, oh, well, I'm not gonna write the try-catch code here, my caller can deal with it. And then that bubbles up the stack to the top level of the application, and suddenly you're getting paged at 2 in the morning for an unhandled promise rejection. So what do I want out of errors as values? Well, ideally, I would like a composable type like the result type found in OCaml and Rust, but I would be equally as happy with a less ergonomic error type like Go uses. I also want the compiler and the LSP to enforce explicit handling of the unhappy path up front. I want to be able to strongly type my errors. I want to give context and meaning to my errors. I want to be able to let my callers decide how to handle the variety of errors my code can produce. Maybe, a file not found error isn't meaningful to the caller and they can just ignore it, or maybe that should crash the process. I want to avoid control flow interruptions. This is what try catch is, right? You interrupt control flow, bubble up, collect the stack, so on and so forth. All of these together promotes more reliable, stable, and maintainable software. I also want sum types and pattern matching. As I described earlier, sum types are pretty much enums on steroids. And in fact, the sum types in Rust are literally called enums. Enums let us encode meaning along with our data. Sum types and pattern matching together let us express, model, and safely handle complex data structures and control flow with ease. It lets you be very declarative about the state of your application and the code paths it can follow. And we heard twice in this conference already from 2 different speakers the benefits of making illegal states unrepresentable at the type level. We want to guide our developers to doing the right thing and make doing the wrong thing as close to impossible as possible. And we also, with pattern matching, get exhaustive case analysis. So we actually do kind of have this feature in this TypeScript world, where if you switch on some value and you don't handle all of the cases, the compiler is going to yell at you and be like, hey man, you didn't handle XYZ cases. You need to either have a catch-all clause or handle these. I also want first-class concurrency, right? We've already talked about the value of having baked-in concurrency. Also, another reason that I have started to move away from using Node on the server. As soon as you get into wanting or needing to do concurrent things in JavaScript and Node and TypeScript, you have to solve that problem with infrastructure. Our last talk, literally talking about using temporal to solve these problems. I'd also like it to embrace the actor model. The actor model is just a really simple way to wrap your mind around handling concurrency, and it removes the need for a lot of complexity, which we'll cover in a second. I want to have lightweight, isolated units of computation, preferably actors, powered by green threads. So green threads are what power Erlang and Elixir's processes. It's what powers Go's, Go routines, Tokyo's tasks. And what green threads are essentially like 4 kilobyte size processes that is managed by a scheduler, a preemptive work stealing scheduler that lets you you can blast off millions of these things at one time and do it all concurrently. I also want simple cross-process and type-safe communication via message passing. I would like to have fault tolerance through supervision hierarchies. So I would like to be able to spin off these concurrent processes, and I would like the process that spawned them to dictate what should happen when a child process encounters an error. Should it just not spin up? Should it spin up n number of times? Should it retry? What is the interval it should retry? Should it always restart? I want to be able to easily scale from a single core on a CPU to fully distributed systems. And embracing a actor model reduces the need for low-level synchronization primitives such as mutexes, semaphores, and read-write locks. I also want a strong emphasis on DX. I want it to be a core value of the language I'm working in. I want it to be simple, friendly, and opinionated, right? These are the lessons I took away from writing in languages like Go and Lua. I want there to be one obvious way to solve common problems. Don't make me go searching through the docs for how to use some syntax. Don't give me this is kind of a problem in OCaml and even more in Haskell. You can solve problems dozens and dozens of ways, and you can get so caught up in building the abstraction, not so different than Java devs and C# devs, building out the entire gang of for-book patterns. I want a unified and modern tool chain. I want package management, the build tool, formatting, documentation generation. I want that all in one binary. I don't want to have 5 different tools to do all these things. I don't have to be updating my prettier or biome version all the time. I just want one version that's baked into the language. I want approachable, searchable, and thoughtful documentation. I think 2 languages in particular that get this really right is Elixir with hex docs and Rust with cargo docs. They're top of the line. You can generate docs easily from cargo or from mix. It's just an amazing experience. I also want friendly and informative error messages. I think two languages that get this right are Elm. Has anyone written Elm in here? A couple. Elm, hands down, has the best error messages across any language ever. Rust adopts a similar style to Elm error messages, just a little bit more complex just due to the nature of the language. I want fast compilation times, and I want the language to favor backwards compatibility, and more specifically, language simplicity over excessive flexibility and features. Code once, run everywhere. I want a language, my ideal language, to embrace versatile compilation targets and runtime environments. I don't want to have to be switching from TypeScript to Go or to Rust. I just want to work in one language and be like an expert in that language, and I want it to be flexible. I want support for compilation to JavaScript so I can run it in the browser or on the edge, and I want to be able to easily bind to existing JavaScript packages. I want to be able to share my types across the front end and the back end. I would love to have support for serverless and edge environments. I also want simple cross-platform support, and a huge plus would be having native and WASM targets. So, as many of you are probably already aware of, I haven't been completely honest about my programming language journey. There is another language that I've been working with for roughly the past 7 months. That language is Gleam, your next favorite programming language. This is also Lucy, the official mascot of Gleam. As described on the Gleam website, Gleam is a friendly language for building type-safe systems that scale. Gleam is a sibling language to Elixir and Erlang that runs on the Beam, otherwise known as the Erlang VM. Gleam uses a simplified implementation of the type system found in Haskell and OCaml. But wait, there's more.